Yes, so now we shall also attempt a demo module for the EV class for the electric vehicle and hybrid vehicle class. And the demo module for this is battery balancing. Yeah, so I guess we can start. I'll let the learning
Introduction.
platform.
If all cells have the exact same charge, then the HV battery is in balance. The state of charge, SOC, can be determined by measuring each module's voltage. If the modules in an HV battery are not balanced, then the voltages may very well differ more and more over time. This would result in a deterioration in the HV battery's SOC, eventually rendering it defective. Find the control unit that collects information regarding the HV battery.
See where I'm putting the cursor here?
OK.
We'll go to the next question.
When is the HV battery in balance? When all cells have the exact same temperature. When all cells have exactly the same weight. When all cells have exactly the same voltage.
I believe it is the last answer.
OK. What does it mean if all cells have the same cell voltage? Then the SOC of each cell is the same. Then the pressure in each cell is the same. Then the current in each cell is the same.
I believe it is the first answer.
Correct. The battery is then in balance. You have read the vehicle's diagnostic system. What is the lowest cell voltage in this HV battery? Round off to 3 decimal places. Fill in an answer.
I believe the voltage is highlighted in yellow. Must be the lowest of the entire pack. We have 3 blocks, each one with 21 cells. So the lowest is these two. 3.542, 3.542, 3.547, 3.54. So I believe it is 3. In this case, I have to type it out in the answer bar. 542. So let's check. And that's correct.
Correct. What happens if the HV battery is not kept in balance? The voltages will differ more and more over time. The voltages will always have the same differences. The voltages will differ less and less over time.
I believe it is the first answer.
Correct. The module's SOC will also differ as a consequence.
So we move to the next question.
What happens if the HV battery becomes more and more imbalanced? The HV battery becomes defective. The HV battery gets more energy. The HV battery loses capacity.
So here we have true or false answers. For the first statement, yes, it's true. No, the second statement is false, I believe. And for the third, yes, that's true.
That's right.
So now we've run out of questions for this page, so we move to the next page by pressing this white arrow at the top on the right.
Balancing. In a series of cells, the worst cell defines the quality of the total pack. The fullest cells are drained until all cells have the same SOC. Now the pack can be used optimally. When the battery is charged, the fullest cell in HV battery will reach its maximum first. As a consequence, the other cells are no longer charged. When the HV battery is drained, the cell that is the least charged will reach its minimum first. As a consequence, the other cells are no longer drained. This is how capacity is effectively lost. This is a representation of 4 cells. Which cell is charged up the most? Cell number 3. Cell number 1. Cell number 2. Cell number 4.
I believe that's the fourth answer. Cell number 4.
Correct.
So for this, I believe the second answer is correct.
That's right.
Go to the next question. Oh, I actually have instructions.
You can charge and drain the cells using the buttons. Completely charge all cells.
Completely charged means I do that multiple times until it won't charge anymore. Yeah. So
Okay.
yeah, so I move to the next instruction or question.
When can you charge no longer? When the fullest cell has reached its maximum. When all cells are full. When the emptiest cell has reached its maximum.
I believe the first answer is correct.
Correct. This is a safeguard against overcharging. If you charge a cell too far, the cell voltage gets too high.
Okay, next question.
Why are all cells charged and drained collectively? Because the cells are in parallel. Because the cells are in a mixed circuit. Because the cells are in series.
I believe the last answer is correct. You can see from the schematic here,
Correct.
these
Because the
cells,
cells are in series,
cells
they
are
are
connected
charged and
in
drained
series.
collectively.
Next question.
In this overview you can see how much capacity these cells have lost. What is the lost capacity? The difference between the most full and the emptiest cell. The uncharged part of the fullest cell. The sum of the most full and the emptiest cell.
So guys, what do you think the correct answer is here? I believe it is this one, the first one.
Correct. This is the part of the emptiest cell that remains uncharged when the full cell has reached the maximum cell voltage.
Okay, next question.
Find the part that represents the lost capacity.
So this is where the system is asking you to point the part that represents the lost capacity out. So you move the mouse there and left click.
That's right.
Yeah, this system is nice. It's interactive like that. I'm sure you two are learning a few things right here.
How can you reduce the difference between the most full and the emptiest cell? By decreasing the SOC of all cells. By equalizing the SOC of all cells. By increasing the SOC of all cells.
I believe the second answer is correct.
Correct. This happens when the battery is balanced. The battery control unit can drain individual cells. By clicking the button under a cell, you can drain that specific cell. How can you equalize the SOC of all cells? By draining the fullest cells until they are equal to the emptiest. By charging the emptiest cell completely. By draining the emptiest cell completely.
So all we have here is the ability to discharge each cell individually. So I believe the first answer is correct.
That's right.
So now we get an
Equalize the
opportunity
SOC of all cells.
to do that. So the second cell has the lowest state of charge, so we are going to discharge all the other three to the same state of charge as the second one. So we begin with the first one. I'm clicking on this discharge button. I think I got there-ish. Yeah, maybe once more, yeah. So we go to the third one, repeat that. I'm clicking multiple times now to save time. I believe we got there. Then the last one, the fourth one, do the same thing. It will take a bit more clicks. I'm clicking like crazy. We are there-ish. So now we check. Yeah.
Correct. The lost capacity is completely remedied.
Okay, so
Completely charge all cells again.
So that means I use this button here. It will charge all of them. That was one click, 2 clicks, 3 clicks.
Correct. All cells can now be completely charged. What can be said about these cells? The cells are not in balance. The cells are in balance.
Between you and me, the correct answer is the second one, the bottom one. But just for just for giggles, I'm going to, well, not for giggles necessarily, but I just wanted to show you what would happen if you gave the wrong answer. I want to show you how the system will correct you and guide you to the correct answer. Remember, when you give the wrong answer, it will score you accordingly, but it will still guide you to the correct answer. So I'm just going to say, I know this statement is incorrect, the first statement is incorrect. So I'm going to click on it anyway so that you see what happens. So now when we check, it says that's not right. If I go
That's not
back,
right.
of course now there's only two answers, so it means it's the other answer that's right. Yeah, in a simple way, I
Correct.
wanted to use that
This
to show
battery is
you.
balanced.
Wanted to show you what happens if you get the wrong answer. It's not the end of the world.
Charge and drain all cells a few times.
Charge and drain them. They are fully charged now. I'm going to discharge them all the way. I'm long clicking on the left, long clicking on the left again. You see the cells have started getting differences. You can see cell 4 is the strongest and cell 3 is the weakest. Already, you can see the differences growing.
Correct.
Yeah.
What happens when you use the cells? The balance improves over time.
I don't think
The
so.
cells keep their original capacity.
No.
The imbalance grows over time.
True. So we move to the last
Correct.
question of the module.
Balance the
Um,
battery.
okay, now we have instructions to balance the battery. Now, of course, that means we look at the one with the least state of charge, which is the third one, and we discharge all the other three to the same level as the third one. I've done the first one, I'm on the second one, almost there. Yeah, and now I'm on the fourth one. I don't do anything to the third one because that's the one with the least state of charge. You can see the recovery process is going on. Now we check. Yeah, the battery is now in balance. And that's the end
You have
of that
reached the end
module.
of this module.
Okay, thank you.